I'd love to officially kick things off. My name is Ava Goodale. I'm the coordinator of the Catskill Science Collaborative, and want to thank everyone for joining our webinar this evening. Especially, I believe we have some students from Deerfield Academy, so I would like to especially welcome you all. But thank you all for being here. Thank you for our panelists for joining us. We're very excited to share the work of our fellows that are part of the Catskill Science Collaborative's Research Fellowship Program. So without any further ado, let's get started. Just as a quick overview, we will introduce the program of the Catskill Science Collaborative and this research fellowship, and then we will enjoy our time hearing from both of our fellowship teams on the projects that they've carried out over the course of really about the last year. And then we'll save some time at the end for questions from the audience and take it from there. So I'm going to hand it over to Josh Ginsberg to introduce himself and the start of our program.
Thank you, Ava. I'm Josh Ginsberg. I am the director of the Catskill Science Collaborative and more probably frequently the president of Carey Institute. I want to talk a little bit about the Catskill Science Collaborative and its formation. I think most of you know this, but for those people coming in new to CSC, I'm going to just use the acronym. It was started by Gary Lovett in November of 2018, after we received a grant from the New York State Department of Environmental Conservation's Environmental Protection Fund. It was an idea that came about in collaboration with the Catskill Environmental Research and Monitoring Program. In long discussions over the years, CERM does many things, but their sort of premier activity is every couple of years, they have a seminar series or a meeting that brings together people who do research in the Catskills. And we all began to realize that we were all a little bit old and a little bit gray, and some were a little more than a little gray, and that we really needed to catalyze new research in the Catskills and a new generation of researchers, both the academics and their students, but also that it was important to bring together what we knew about the Catskills and create a database for both data sets and for publications. And finally, to tell people about the wonderful things that are happening in the Catskills from the perspective of science and the application of science to management. And that really is what we have focused on. It really is a remarkable process whereby we pair up students and their mentors at the university with active managers in the field. And we do that with predominantly, but not entirely, the New York State Department of Environmental Conservation and the New York City Department of Environmental Protection in the Ashokan and Round Out Never Sink SMPs. And of course, Carey Institute sort of oversees this and hosts it. Ava, do we go to the next slide? Why don't you, Ava? I mean, this has been so much for the last few years, a part of what you do every day. I think you should probably talk about how we do this.
Absolutely. Thank you. So the goals of the Catskill Science Collaborative really boil down to communication and collaboration between those doing environmental research in the Catskills, which is really in line with much of what Josh just shared about the motivation around its formation. So we're focusing really on three main groups to achieve those goals, and that is members of the public, researchers, and managers. So the main interface with between researchers and the public are through events like tonight and several others throughout the course of the year. And then we put a great deal of emphasis on bridging the gap that often exists between researchers and managers in settings across the world. So this is not unique to the Catskills, but to solve that problem in this region, we have done things like Josh mentioned to promote the work of CERM and support the CERM conference. We host a data portal and a public-facing reference library that is all focused on the Catskills, really bringing research findings into a more accessible and public space. And then the focus of our program this evening is really the research fellowship, which like Josh said, is a partnership between a student, which could be an undergraduate or a graduate student, their academic mentor in the research space, and then a natural resource manager working in the Catskills. And what is unique about this program is that we start the process of these fellowship teams by asking managers what are their needs on the ground, what research do they need to promote the work that they need to do. And then we engage researchers and students to form teams like you'll hear tonight. And the role really of the Catskill Science Collaborative is to facilitate the fluidity of that knowledge exchange, and really serve as a knowledge broker, bringing these groups together and helping form these collaborations and then celebrate their success, which is what we're doing tonight. So in that way, the research fellowship primarily is designed to have fellows have a positive research experience that will give them professional skills and a unique skill set in that they have both research and management experience. And like Josh said, to attract the next generation of young scientists, especially to the Catskills, all while supporting managers in this region so that their research needs are proactively met, so that there is an evidence-based research approach in this important region. So with that introduction, I'm going to hand it over to our first fellow, Adrian Maleszewski. And he is an undergraduate student at SUNY Oneonta, majoring in geology. He is a member of the Geology Club and the Earth Science Honor Society. And I'll turn it over to Adrian to introduce his project and his team of professionals who have supported him to get this far. So Adrian, I will hand it over to you.
Oh. Right. Hello, everyone. My name is Adrian Maleszewski. As Ava just said, I'm currently a senior undergraduate student majoring in geology at the State University of New York at Oneonta. Over this past summer, my professor, Dr. Les Hasbargen, and I experimented with a new localized survey methodology in the Catskills with support from Dany Davis of the New York City Department of Environmental Protection. We surveyed 2 different locations using pole-mounted structure from motion photogrammetry. Before we begin, I just wanted to acknowledge a few people who are crucial in our survey efforts. First and foremost is Dr. Les Hasbargen, of course, who initially introduced me to this technology and acted as a mentor throughout the entire process. Dany Davis, a stream studies coordinator for the New York City Department of Environmental Protection, for guiding the direction of the research and just being a generally super helpful resource. There's too many things to list. Emily Belinsky, a coordinator for the SUNY Ulster Watershed Conservation Corps, who helped us establish ground control points at the Warner Creek site. Michelle McDonough of the Greene County Soil and Water Conservation District for getting us access to the East Kill site. SLR Consulting, especially Matt Truehart and Ethan Ely, for providing existing survey data for comparison at the Warner Creek site. And of course, the Cary Institute of Ecosystem Studies for their generous grant, and specifically Ava Goodell for being our main point of contact with the Institute. Going into the project, we had a few main goals in mind. We essentially wanted this to act as a proof of concept for the methodology. With existing drone-based surveys, you face some inherent issues. Vegetation and trees are unavoidable. Flyover surveys simply cannot capture below trees and dense vegetation. And although some modern LiDAR scans can effectively filter and remove this vegetation, these are often expensive and not viable for localized return surveys. And while existing public New York State drone-based 1-meter LiDAR surveys are excellent at providing accurate general topographic data over an area, the data points are just not dense enough to take accurate measurements of topography over a specific cross-section, for example. If you're focused on a specific point of interest or cross-section, you simply have to conduct your own survey and gather your own data. Using structure for motion photogrammetry, we are able to conduct localized surveys down to a resolution of just centimeters. We wanted to document the exact methodology we use to survey more efficiently and produce such high-quality data. Lastly, the project acted as my first introduction to conducting my own research, and I was very excited about the idea of gaining such firsthand experience. Structure for motion, or SFM, allows for a 3D reconstruction of a space using 2D images. As the name implies, in its most basic form, you move around a structure, shooting photos from different angles and depths. These photos are then aligned in a 3D space and are essentially stitched together pixel by pixel. On the slide is the first ever point cloud I processed of a brachiopod fossil. This was actually in one of Les's classes. The level of detail I was able to achieve had me interested in the possible application of SFM over a much larger scale. We visited several sites during the summer and ended up settling on 2. We have the Warner Creek site outside of Phoenicia, New York in Ulster County, and the East Kill site outside of Jewett, New York in Greene County. As you all can see, these sites are in rather strong contrast to each other. We have the Warner Creek site, which in 2021 underwent an extensive and expensive restoration project, and the East Kill site, which currently has an active landslide phase and will soon undergo a restoration project of its own. We believe picking such different sites would allow us to better show off the method's range of applications and just how effective it really is. The methodology involved is actually surprisingly simple. The first step, as with any survey, is just figuring out exactly where you are. By using a total station on a known point and shooting coded 12-bit targets, you can establish several known ground control points in the survey. These targets can be seen scattered throughout the site on the far right image. Scattering the targets in such a manner allowed for a significant number of photos to capture at least 1, if not 2 or 3 of these targets. This greatly strengthens the program's ability to accurately project the locations of these known points. If you don't have a total station readily available to you, we found that GPS receivers are a good alternative. Using just 3 GPS receivers, we were able to get a near perfect alignment with just those 3 coordinate points. While GPS receivers are a bit less accurate than total station data, the time you save by not having to set up and shoot 10 or more targets makes it a viable alternative if you have enough receivers. And for every additional receiver you add, your points and eventually your alignment, hypothetically, should be more accurate. I will come back to alignment shortly, but the more accurate known points you have in your workspace, the better the software is at aligning and resizing the point cloud into a real-world frame. Once your targets are shot and the coordinates are recorded, it is time to start taking photos. Well, I took photos on a brand new GoPro 11, which costs about $400. Dr. Hasbargen got surprisingly comparable results on a knockoff action camera he had purchased years ago. The cameras were placed on approximately 15-foot tall poles at approximately a 45-degree angle towards the ground. This allowed us to capture an adequate area per photo while maintaining a good pixel quality. Looking at the figure on the right, any area shaded in dark blue, which is about 99% of our survey reach, was captured in at least 10 different photos. Ideally, you want the whole area of interest to be shaded in dark blue. There was a lot of discussion about the most effective paths and techniques to use while actually taking photos. While it may be overkill, my PC is able to handle over 1,000 pictures at a time, so I settled on a rather photo-intensive path. The path I took can be seen on the right. I would shoot from one bank to the other, taking a photo approximately every meter until I reached the end of the survey area. About every 20 meters or so, I would do a 360 pan, taking photos around a fixed point. This would take about 10 photos. I then would wade up and down the stream, again taking a photo of the stream itself with meters every meter, with pans approximately every 20 meters. Then I would again photo from bank to bank, but from the opposite bank. Any surrounding vegetation or floodplains would typically be captured towards the beginning or end of the survey, depending on what made the most sense with the site. Looking at the aerial view of the Warner Creek site on the right, you can see that there are some bits of blue where we just don't have any points. There's a variety of reasons that data could be missing like this. For this particular survey, we believe the data is missing because of wind. We were out on a day with a breeze, and with swaying vegetation, you're bound to have points moving in between photos. I believe the empty spots in the floodplain are a result of plants swaying too much between photos for parts of it to be detected as constant points. Once these photos are taken, they can be brought into any photogrammetric processing software like Agisoft Metashape. A standard license of Metashape is $180, while a professional license is $3,500. Free open source options like Meshroom or WebODM will also work, but I found WebODM to be much less user-friendly than Metashape. When I was first shown this technology by Dr. Hasbargen, I was astonished. In about 40 minutes, the software is able to align the camera locations for the photos in a 3D space to form a sparse cloud, which is a visualization of tie points or points shared by multiple photos. You could already start to see the shape of the landslide face at the Eastkill site with 792,000 points. According to the processing report, alignment of 925 images took 35 minutes and 9 seconds for the Eastkill site, and alignment of 1,343 images took 51 minutes and 57 seconds for the Warner Creek site. These photos were aligned on the highest quality setting in a sequential manner, with the program assuming the photos were taken in sequential order. Any photos that fail to align can either be realigned to their estimated locations or simply removed from the survey entirely if not needed. Keep in mind that these times are based off my PC specs. Metashape is incredibly CPU intensive, and I often found my CPU sustaining 99% use for extended periods. For reference, my system was built for about $1,200 back in 2020. As the technology advances, I would definitely recommend over 16 gigabytes of RAM and a strong central processing unit. Once you have your sparse cloud, in just an hour or two, depending on your PC specs and the number of points, the program can build a depth map and dense point cloud from the sparse cloud. These point clouds are essentially high-resolution 3D models. Just look at the landslide face. You can see every little crack and crevice that is formed. This dense point cloud has over 29 million points, more than 35 times that of the sparse cloud. Sadly, due to consistently harsh stream conditions over the summer, I was unable to wade up and down the stream itself at the Eastkill site. This led to a big gap in data in the channel as I just wasn't able to adequately photo the stream bed. The gaps on the landslide face themselves seem to be caused by portions of the face being obscured by vegetation below. Depth map and point cloud generation took 54 minutes and 3 seconds for the Eastkill site and 1 hour, 8 minutes and 35 seconds for the Warner Creek site. Point clouds were generated on the medium setting with aggressive depth filtering. We found that the medium setting provided data that was more than adequate, as the almost unnoticeable increase in quality that the high setting produces was just not worth the exponential processing time. For example, while making my first point cloud for the Warner Creek site, I originally ran the point cloud at high and was met with an estimated time of about 5 hours for just the depth map, putting the total processing time with the point cloud at just over 10 hours, which is about 10 times longer. If you're using a total station, you can then detect the targets that were placed down before. And by importing a text file with the coordinates that were previously shot by the total station or captured by GPS, you can automatically rescale and align the point cloud with those known points. This took 3 minutes and 30 seconds on the Eastkill site and 4 minutes and 10 seconds on the Warner Creek site. If your ground control points and total station data are accurate, the point cloud is now in a real world and, more importantly, comparable frame. After about 3 hours of surveying, and if everything goes well, just about 2 hours of waiting for the point cloud to process, you're ready to move into GIS. First, you export the file as a .laz and import it into any GIS software. While I personally use QGIS, which is an open source and widely used software, other programs like ArcGIS or Global Mapper should work just the same. Once you import your point cloud, QGIS will automatically begin to load it into the workspace. I then imported existing orthoimagery, DEM data, and LiDAR data from New York State Clearinghouse into the workspace, which are all publicly available. Once your data are in the proper coordinate systems, all of your layers should be overlapped. Once your data is aligned like this, a few comparisons can be made. Right off the bat, you can visually compare the point cloud to existing orthoimagery. This could quickly show you if any significant mass transport has occurred since the imagery was taken. As you can see, the point clouds seem to align perfectly with orthoimagery, meaning we need to dig a little bit deeper to detect any change. Being able to detect change at a small precision was one of our initial goals with this project. We wanted to be able to measure exact topography over specific cross-sections at the sites. The following 2 slides of data were measured at the Eastkill site along the profile on the current slide. I'm going to be using the word tolerance a lot in the next few minutes, so I wanted to quickly explain what it means in our terms. If the profile is at a tolerance of 2 meters, for example, the profile would pick all points within a meter of either side of the profile for 2 whole meters. Taking a look at existing publicly available data from New York State Clearinghouse, the 1 meter LiDAR data is simply not sufficient for our purposes. LiDAR is read in QGIS in a similar manner to point clouds, with different points indicating different elevation values. The issue with this is that the publicly available LiDAR data simply does not have an adequate number of elevation points to measure exact cross-sections. Looking at the 2019 FEMA LiDAR profile on the left, there are hardly any points on the line at a tolerance of 15 centimeters. To get a valid profile, you have to raise the tolerance to about 1.5 meters. This means that the profile is picking up any point within about 2.5 feet of either side of the line, which when you're looking for exact cross-sections is not ideal. Comparatively, our pole-mounted data is far more complete than the Clearinghouse LiDAR data. You can see that even at 15 centimeters, our dataset provides a very strong and constant profile. Looking at the point cloud and 1 meter DEM data from 2019, you can already see that drastic change has occurred at the Eastkill site in the last 4 years. Most notably, the landslide appears to have retreated about 1 meter and the channel has widened overall. If you wanted to monitor the exact morphological change that occurs along this profile, both the existing publicly available DEM and LiDAR data simply don't have a high enough resolution to be used. If we were to return to the site next year, within just a day, we'd be able to visualize and begin to quantify the change that has occurred. With thousands of points per meter, our pole-mounted structure for motion photogrammetry method is a quick and cost-effective way to survey sites to far less than 1 meter precision. In fact, we were able to get accurate, constant topographic profiles down to a resolution of just 2 centimeters. For reference, that means that on average, there is less space between data points than the width of your thumb. And while not entirely useful, at 7 millimeters, the results even stay comparable with the existing LiDAR sets we saw before, which were at 15 centimeters. Comparing profiles isn't our only option, however. As the Warner Creek site is currently monitored by the New York City Department of Environmental Protection following its restoration project, SLR Consulting performs drone-based surveys of the site once a year. We were able to obtain the resulting files from one of these surveys and difference the 2 clouds through Cloud Compare, which is an open source point cloud visualization software. Differencing the point clouds compares them point by point to determine the exact change of each point between surveys. I was very excited to see these results. The entire channel, which can be seen in blue, remained near constant. This indicates that our data correlated very well with the existing SLR surveys. The most major change occurs on the floodplains. You can see that between the 2 surveys, significant vegetation has grown, with some growing up to 5 or 6 feet tall in just the 2.5 months in between surveys. We were very glad to see that the path to the site and other man-made topography remained constant. This not only indicates that the stream restoration efforts are working, but that the method does indeed capture accurate elevation data. And if I just clean up the data a little bit, you can see a large spike right around 0 feet. This indicates that a vast majority of the points have either remained constant or moved by just a fraction of a foot. The curve off at the end was a result of that growing vegetation. To recap on some of the bigger advantages of this method. Most notably, this method allows for surveying down to just centimeters. These high definition results allow for measurements and comparisons that just wouldn't be possible with a 1 meter LiDAR scan or DEM. You're also able to capture below the canopy. This allows for surveying in dense forests where aerial surveys just aren't possible. Once you have a good understanding of the method and software, the method itself is easily reproducible and doesn't take much time to conduct. And lastly, the method is relatively inexpensive, and aside from a total station, does not require any specialized equipment. Of course, the methodology is not perfect. The biggest problem we faced was weather. Ideally, you'd want to survey on a dry, cloudy day when the stream of interest is calm and low. Too many reflections from the sunlight can potentially cause processing errors, rain can worsen stream conditions or damage equipment, and a rough, non-wadable stream is just downright dangerous. This summer, we basically had two types of days: torrential downpours or hot, sunny days, with just a few cloudy and cool days scattered in between. If you take a look at the Warner Creek stream gauge, from about late June to the start of August, the stream was running higher and at times significantly faster than average. We decided that we would rather go out on sunny days rather than risking unfavorable or even dangerous conditions on the rainy days, especially with the landslide face at the East Kill site. Because of the sun, reflections off the water led us to initially question the accuracy of the elevation of the points on the stream bed itself. We were glad to learn from differencing the Warner Creek surveys that these were indeed accurate and not affected by reflections off of the water. Another consideration to keep in mind is survey extent. In our cases, the maximum survey extent was about 100-meter reach of stream. While theoretically, one could capture a far greater area, the processing time starts to increase greatly once you get over the 1,000 picture mark. Another consideration is seasonal ground cover. Some vegetation, like the invasive Japanese knotweed, can grow so dense and thick that traversing through it with a pole just is not possible. Another one of the biggest issues we faced was the software learning curve. Figuring out the different tools and options available was incredibly time consuming, and we are still finding new ways to improve our results and work more efficiently. The software isn't always perfect, of course. Agisoft Metashape especially can be very finicky. We faced a common issue where a group of photos would fail to align and would lead to a weird layered surface effect. While this can be quite an easy fix, I lost one entire day of surveying after my first Warner Creek photo set just wouldn't align properly at all. While we had used this method to survey localized turbidity sources in the Catskills, there are countless other possible applications we have in mind. Other than a localized survey, we believe that this method could be used to effectively monitor and track vegetation growth, which we have already went into at the Warner Creek site. With a return survey, you can difference your results and potentially calculate the exact rate of growth of vegetation. The method can also be used to monitor trail conditions. We have already experimented with extracting frames from video to make point clouds and found that you get surprisingly strong results using this method. By simply recording both the route in and out, the frames from the video can be extracted and used to build an accurate point cloud of the entire trail. You can also monitor channel bed morphological changes. This is something we want to explore at the East Kill site. As mentioned before, there seems to be some channel widening occurring there. We are hoping to see even more change during the return visit. Being able to monitor the exact shape and width of the channel is a huge potential application of the method. Something we also explored at the East Kill site was landslide monitoring. From comparing our data with existing New York State surveys, we can already see that significant change has occurred on the face. With a return survey, you'd be able to difference the results and potentially calculate the mass of sediment that is eroded in between surveys. Another potential application is channel debris monitoring. Fallen trees and other debris can have drastic effects on stream morphology. Using this method, you can monitor exactly how the debris is changing the stream, as well as tracking any debris movement itself. We are still actively working with this method and have some future plans in mind. We are interested in integrating our data and methodology with other existing methods used in the Catskills. By integrating our methodology with drone-based surveys, for example, you can capture surface level features that previously wouldn't be visible while also allowing for a broader survey area. We're also curious to see what kind of results we can get with a 360 camera. A single 360 photo would essentially equate to an entire 360 pan, which takes us about 10 photos currently. We are interested to see what kind of results you can get with just 4 or 5 of these 360 photos, rather than hundreds of regular images. As mentioned before, something that has fascinated me was being able to see exactly how the East Kill site has changed since 2019. This got me curious about exactly how much the landslide face has changed since 2019. Could we possibly calculate a volume of sediment that has eroded into the stream? We hope to find that answer in the coming months. We are currently planning to return to both sites to perform a follow-up survey. Ideally, a return survey to the Warner Creek site should be nearly identical, while the East Kill site should see even more change. I'm excited to be able to difference the initial and follow-up surveys to see exactly how much change has occurred. In the spring, I am planning to attend the GSA Northeastern Section meeting in New Hampshire and the Southeastern Section meeting in North Carolina. I hope to be able to present these further findings at those meetings. Lastly, I'm currently in the process of applying for graduate schools, and I hope to pursue a master's degree within the field of hydrology or water resources. Please feel free to reach out with any further inquiries. And now would be the time for questions, but I think we're doing that at the end.
Yes. Thank you so much, Adrian. That was fantastic and really impressive to see everything you were able to do with this project. And I'm sure there will be many questions from our audience. So, well, we're switching gears right now, so we can, Adrian, you can stop sharing, and Danielle, you can start. But while we're switching gears, folks in the audience, you're welcome to submit any questions you have now for Adrian in the chat, and then we'll look at those toward the end of the presentation. But for now, if you have any that are right on the front of your mind, you're more than welcome to put those in the chat right now. And we're ready to hear from our second fellowship team. This is a group of young researchers. Danielle Takacs is an undergraduate at SUNY New Paltz, majoring in biology. She has a great deal of experience working with birds, from breeding bird surveys to bird banding. And she was joined by Samuel Mateo and Kristyn Gessner, who are both avid hikers, and you will see why that is such an important trait for this project, and also very experienced birders, and they're recent graduates of SUNY New Paltz as well. So this dynamic trio will walk us through their project and their fellowship team. So I'll hand it over to you all.
Hello. Hi, everyone. Can you guys hear me? Okay. Thank you for coming to watch this presentation. As the title suggests, our goal for this past summer was to investigate the impact of human visitation on montane breeding bird populations in the Catskill High Peaks. As part of an ongoing process of developing a visitor use management plan for the formerly trailless Catskill Peaks, we partner with the New York State Department of Environmental Conservation, the New York Natural Heritage Program, and the Vermont Center for Ecostudies under this Catskill Science Collaborative. My name is Danielle, and I will be presenting with my friends and my fellow field technicians, Sam and Kristyn, who helped me carry out the data collection portion of this project. Okay, so we were guided by our former SUNY New Paltz professor and ornithologist, Dr. Kara Belinsky, as well as statistician Jason Hill, natural resource planners Sara, Hart, and Pine Roars, and then ecologist Max Henschel, and director of science Tim Howard. It's been really wonderful working with all of these different scientists from different backgrounds. So I hope you guys enjoy our presentation, and I'm going to pass it off to Sam to give you a little background about this project.
Okay, hi everyone. Let me put this here, okay. So since the start of COVID, there has been a worldwide increase in outdoor activity, mainly hiking. And with apps such as AllTrails, Gaia, and Strava, hiking has been more accessible than ever before. Not only can you plan your routes beforehand, using detailed information about the trail, as you can see on the bottom right. That's actually a screenshot from when my friends and we went to the Adirondacks, and we used AllTrails to plan around our trip to the peaks of the Adirondacks. But not only were we able to plan ahead, we were also able to track our progress along the way using this app. And here's a graph of, here's a graph showing how popular the Catskills are as a hiking destination, and particularly during the COVID pandemic, or the height of the COVID pandemic, from 2019 to 2020. And here you can see an 86% increase in the amount of hikers who were reaching the trailless peaks and signing in their names in the notebooks at the top, located at each of the top of the peaks. And although the number started to level off after 2 years, it's still a big increase from before the pandemic even started. And not only is hiking more accessible than ever before, it's kind of more fun than ever before. With said apps and hiking groups such as the Catskill 3500 Club and Hikers Anonymous, you can hiking is almost like a game, if you think about it that way. You can track your own personal records on certain routes. You can fight for your spot on the leaderboard and even complete certain challenges to win rewards. A common challenge for advanced hikers is to peak bag or to reach the summit of many peaks, particularly sometimes in one season or from multiple directions, earning you a badge or a patch that you can show off to your hiker friends. The screenshots you see on the left are from one of my best friends who uses Strava to run or to record his runs in Boston, mainly Harvard Bridge. The image on the right is from him running on the Harvard Bridge, and you can see his personal record at the bottom and how he compares to the left of those runners who also use Strava to record their runs, and currently he's sitting in third. But so yes, hiking is like a game where you're not only just wanting to do it now, but you're wanting to do it more often to do better than you did last time. And although we love that everyone's enjoying the outdoors, we have to understand that hiking impacts wildlife. And namely when a lot of these mountains are not being or do not have official trails. So a lot of hikers are creating their own paths or bushwhacking. And as more people bushwhack, it becomes a herd path. And as more people follow those herd paths, it becomes an informal trail. As you can see on the image on the left, there's Danielle and I following an informal trail on the Southwest Hunter Peak. And if you're a new hiker, you would never guess that this isn't an official trail. This is particularly important, especially with birds, because our presence disturbs what they naturally do. So we've noticed in the Catskills that birds are singing less during the breeding season. They are being seen less. And then sometimes in drastic cases where the presence of hikers is just too threatening to them, they will abandon their own young. And this is shown from the studies conducted by the Vermont Center for Ecostudies over the last decade, where many of the high elevation species, their populations are declining drastically over the last decade. The reason why we focus on the Catskill High Peaks is because there are 33 of them over 3,500 feet. And for most of them, they contain spruce and fir forests with some beech and maple mesic areas sprinkled in between. And the reason that's important is because it is a unique subalpine habitat that is a perfect breeding ground for many of these species. And unfortunately, due to climate change, they're facing an increased difficulty in accessing those suitable habitats because of the upward shift of low elevation communities, such as low elevation birds and vegetation that are creeping up and are competing with them for these resources. So again, bringing it back to the montane birds, the reason why they're so important is because they serve as a biological indicator for these habitats or ecosystems. And by monitoring their populations, we can get an idea or have some insight on how the Catskills are doing. And as I showed you a couple slides earlier, their populations are declining drastically. So what does that say about the Catskills? Which poses us to our research question: what is the impact of proliferating informal trail networks and bushwhacking hikers on the bignut thrush and other breeding montane birds? There are many other studies that provide evidence as to why hiking is detrimental to wildlife, but a lot of them focus on formally trailed peaks and didn't really focus on herd paths and informal trail networks. And land resource managers, they work to maintain a balance between human recreation and sensitive wildlife. So this information is extremely vital for them to make their decisions. I'm going to be passing this off to Kristyn.
Hello. So kind of bouncing off of what Sam just said, there are a few studies that were published recently that acted as prerequisites to this study and were really stepping stools for some of the decisions that were made for this one. The New York Natural Heritage Program looked at the influence of informal trails on natural communities in the Catskills in a paper that came out in 2022. And New York State DEC published a handful of papers looking at the condition and location of nearly 40 miles of visitor-created informal trails on the trailless peaks that are over 3,500 feet in the Catskills. And these papers provided us a bit of a baseline, or at least our collaborators, a bit of a baseline on where to go with where we were studying. So the peaks for our project were selected with a handful of different parameters in mind. Jason Hill from the Vermont Center of Ecostudies used topographic maps, aerial footage, and data from the Strava app to determine likely tree communities and trail usage along several different peaks, as well as the location for possible future informal trails along the peaks, which were likely or are likely to be along ridge lines. So these are trails that are informal trails with lower visitation that may one day become trails. So these classifications were established formal trails, which look something like this orange outlined picture and include peaks for people who are aware of the Catskills, peaks like Hunter and Plateau that have very apparent trails. Then the next classification were informal trails with high visitation. So these are not established trails, but you basically can't tell that from a lot of the images that we're going to show, that they really look like, because of the high level of visitation, like formal trails. And the last classification are informal trails, and these have low visitation and are basically barely visible. To a new hiker, you might not see these at all, and there were a lot of point counts that we conducted that did not look like they were near trails. But these are located in places that may one day become formal or informal high visitation trails. So just to give you a little taste of what it's like to conduct a point count, this is how we collected our data about birds. So we use something called Mountain Birdwatch Protocol. I'm sure a lot of people have heard of it. It is a citizen science program that's been running for almost 2 decades, and it's through the Vermont Center of Ecostudies, and it looks at the health of montane bird species populations throughout the Northeast. Historically, there has been very little or no data collection on the trailless peaks in the Catskills, and that, for us, looked like a better opportunity to understand the birds that are there. So here you can see 8 of the focal species for this project that are, or 8 of the focal species for Mountain Birdwatch specifically, that are present in the Catskills. The way that this protocol works is that we start 45 minutes before sunrise and aim to finish by 10 a.m. We stand at the center of the circle, which is visible here, and we imagine what 50 meters around where we are standing would be, or most of the times we measured it. And we identify the species that we either hear or see. Usually we hear because it is quite dark, and we mark where we believe that they are. Then we conduct 4 back-to-back 5-minute point counts. So you'll see here on this data sheet, it says point count period 1. That's the first 5 minutes. And we conduct 4 of those. And we look for these 10 focal species, and in our case, 8 of them, and also red squirrels, which we did not hear any. So to classify the locations that we were conducting these point counts, we did trail surveys and vegetation surveys. The vegetation surveys consisted of vegetation community composition, vegetative layers in the under, mid, and upper story. So you can see us collecting vegetation survey data here. We collected the DBH of the widest tree at the point and the presence or absence of balsam fir. The trail classification consisted of the different classes of trees, or not trees, sorry, of trails that ran through the points that we were conducting the point count surveys at. So the first class, very little foot traffic, and up to the 5th class, which looks like there's an intense use of that trail. So kind of to imagine what we were doing while we were up there, kind of think about how you would classify this trail, which is slightly visible, but not a lot of destruction as of yet. Okay. All right. Okay, so a little bit about the data that we collected. This is a picture of us, or Sam and Danielle, very early in the morning at the first point count. Super dark, probably really cold. We, as a group, identified 993 individual birds that consisted of 27 different species. Our most common species were the yellow-rumped warbler, the golden-crowned kinglet, and the Swainson's thrush. Lumping in data from the Citizen Science Project and the citizen scientists with Mountain Birdwatch, they also contributed 202 more detections that we could add into our data analysis, and their most common species were Swainson's thrush, hermit thrush, and the winter wren. The photos on the right are a very cute little yellow-rumped warbler that we saw one morning, and a mystery thrush, because they are challenging to identify when they're far away and we can't see them that well, and we can't hear their song. But maybe one of you guys could identify.
Maybe it's big nose thrush. Okay, on to the exciting part, which is the results. This figure in the center shows a box and whisker plot of the birds that we detected across different trail types. In green, we have our informally trailed areas with low visitation, and purple is the informally trailed areas with high visitation. And then in orange, we have those formal high visitation trails. Because we incorporated data from the Mountain Birdwatch Project, those folks focused only on target species, while we kind of identified every bird that we could. So this plot here shows only focal species. So the y-axis represents the number of focal species that we detected and across the different trail types. The X in the middle is the mean. The line across the middle is the median. That gives you a different idea of how many birds were detected across the different trail types. Those tails show you the range, and then the little dots are outliers. This graph is really interesting because it shows the habitat least preferred by the birds, at least the focal species, was that one in the middle, which is the informal trails with high visitation. This might be a result of the idea that informal trails are generally thought of as less sustainable than sanctioned formal trails, and therefore alter the vegetative and the soil composition at a greater rate and create less suitable habitat for birds. Additionally, informal trails are generally more difficult to traverse than formal trails, therefore causing hikers to spend more time on the path and then more time in proximity to birds, which is more disturbing to them. Another related, there we go, just a little reiteration, the least suitable trail for birds is that informal high visitation trail. Another very fun finding from our data was the correlation between trail condition class and the number of individual birds detected. Now this figure shows data only that us fellows collected, which includes all birds that we are able to identify, not just the focal species on the y-axis, and then across only informal trail networks, high and low visitation along the x-axis. I grouped each sample point into one of two categories. The first being in green, which is the low condition class 0 to 2, or the high condition class 3 to 5 in orange. Just to reiterate, trails with lower condition class were those that showed few to no signs of disturbance in the vegetation or the soil, whereas those with higher condition classes in orange had areas with no vegetation, soil erosion, and rocks or roots exposed. The latter is generally correlated with higher levels of use and more human foot traffic, but is not necessarily a sampling point that was assigned a high visitation trail. It's a little bit difficult to see all of the names along the bottom, but they're labeled high or low use based on their relative rates of hiker use. The majority of the low visitation points had a low condition class number and vice versa, but not all of them. I also ordered these sampling points in from highest to lowest in the number of birds that we detected, and visually from this graph, we can determine that the left side of the graph shows the greatest number of birds detected and is largely consistent of the lower class trail with less human impact. And then the right side of the graph is mostly orange. So what does this mean? Proliferating informal trail networks are not sustainable, especially as they become more popular and see greater levels of visitation. Not only do they alter vegetation and soil composition at a greater rate, but they also introduce a greater volume of hikers into areas that were previously less disturbed. And as we've seen, human disturbance has a really negative impact on bird species, and the results that we found support that idea for montane birds in the Catskills. Our results tell us that bird populations are largely impacted by hiker presence and by trail condition, and we can also see some similar trends that might be valuable to expand upon. Factors such as trail length and condition class show negative correlation with the total number of individuals detected on informal trail networks. So in continuations of this study, those could be areas of focus, as well as characteristics such as trail width or more in-depth measurements of human travel along the trail. I think it would be super interesting to see if there's a correlation between trail difficulty or the time it takes for people to complete certain trails and the species abundance and richness along that trail. It also might be valuable to investigate the impact of distance from an informal trail on species abundance and richness. So in order to address these issues, the DEC has announced several projects within their visitor use management planning process. You can find a lot of these on their website, but some of the things that they're currently working on is identifying informal trail networks that are good quality, which means that they're not located near rare, threatened, or endangered species. And they will identify a preferred informal trail route to each summit while also working to develop a more permanent solution to the damage that we see caused by these informal trail networks. They're also working on creating formal trails that are designed for long-term use, so they're more sustainable and will prevent further damage to natural resources and lead trail users along an established route. From my experience working on this project and sharing it with other people, I realized that many hikers who love to spend time outdoors are not informed about their impacts on nature. I think visual depictions of vulnerable species along the trails are a powerful message that we share our outdoor spaces with wildlife and we must be respectful of that. Here's a couple things that you guys can do as hikers if you want to limit your impact on breeding birds up there in the Catskills. You can limit your hiking in the muddy seasons, avoid creating your own path, limit hiking during the breeding seasons, and then just be mindful that you're sharing the trail with wildlife. Another thing I love to tell people is to download this app Merlin. It allows you to identify birds in a multitude of ways, one of which is recording the audio, which is a very cool thing, very cool feature. And then once you start walking around and recognizing your bird friends out there, you become much more aware of their presence. So the results of this study provide more evidence to show that off-trail hiking has a negative impact on breeding montane birds. Using data from this project, from vegetation and informal trail surveys completed by Pine and Max, and then visitor data from the canister sign-ins and from hiking apps, and then several years of data from Mountain Birdwatch, the New York State DEC is much more equipped to make those management decisions that maintain human recreation while also protecting local wildlife. So, on behalf of the fellows and myself, I would love to express my deepest appreciation for all of those who have supported us in this project. First and foremost, Dr. Kara Belinsky, who has been my mentor during my entire undergrad experience and has provided us with so much support. To all of our collaborators at the DEC, the VCE, and the NYNHP for always being available and excited to supply just endless supplies of wisdom and information for us. And I would also like to personally thank 35 Club member Patrick for teaching me how to use backpacking equipment because I had never done that before, and assisting us for our first trip up Hunter. And then also for Dany Davis for leading us up Friday Mountain and sharing his experience and knowledge with us. Finally, I'd also like to thank Jim Bouton and Margaret McGrath for teaching us the many secrets of the mountains and then providing our team with whatever resources we needed. So thank you guys for watching and enjoy this beautiful view of the Catskills.
Thank you all so much. And thank you for sharing all these beautiful images with such rich content. And it's fun to sort of imagine your experience and all the adventures you had while you were conducting your study. So while Danielle, if you're okay to, perfect, thank you. We will open it up to some questions now. Folks in the audience, please think of questions that you would like to raise at this time. And if possible, if it's not completely obvious, please direct your question toward which project. It will likely be obvious since they're so different, but that might help. And while those are coming in, again, congratulations and thank you to all of our fellows. It is really interesting and exciting work. And I mean, I think since I've heard and seen these projects develop, it is most exciting for me to see how you guys light up when you talk about your work, and the pride that I can see and feel even through the screen. So thank you all. And we'll say some more thank yous at the end, but Josh, do you want to jump in?
We have a couple questions in the Q&A.
Absolutely. Yes. So, and please keep them coming. So we have 2 questions so far. One is for Adrian. So Steve Gessner, how many total days did you spend at the site to complete the survey?
So actually shooting the photos at each site took just about 3 hours once we actually got the methodology down. We made probably 3 or 4 trips to the Warner Creek site before we actually had our methodology perfected and our results how we wanted them. And the East Kill site was just one day we went in to do the survey and we were done. We had planned to do a return survey of that site to try to get potentially better results, but the weather didn't allow for it. And we were already proud of what we had, so we just decided to stick with it. But yeah, when we go back, it should really realistically be about an hour of setting up and 2 hours of shooting and 10-15 minutes of cleanup afterwards. The biggest time cost is within actually processing and getting all of the software to work properly.
Well, given the results, Adrian, that I think is very quick work, if you ask me. I think those visualizations are incredible. I'm going to get a question out of the chat, not the Q&A for the Bicknell buddies. What other factors besides hiker impact might explain some of the bird count results? That's from Dany Davis.
Okay, I can answer that. A big thing, along with what Adrian said, was the weather this summer was just rain, rain, rain. So we had a lot of trouble kind of working our survey days around that, and that also impacted a lot of our results. We got like quite a few less birds than we were expecting. But another thing from the data that I pulled that was correlated with the bird count results was part of our vegetation survey, which was tree stem density. So we counted the number of trees within our station, and that had like a positive correlation with the amount of birds that we saw. We're thinking probably because a lot of high elevation birds really like dense shrubby vegetation. So our stations that had a higher density of trees were showing us higher detection rates as well. Hopefully that answers that question.
Yep. Ava, we can take turns.
Yes, perfect. I'm seeing another question that I'll actually broaden to both groups. So there's a question, do you see any possibilities for getting high school students involved in these projects? So it'd be great to hear from both projects what you think about younger folks getting involved.
First, or
jump in.
So interestingly enough, I actually had considered reaching out to my old earth science teacher from high school, because he was the person who originally got me into science in general, made me realize I had a passion for it. And I actually wanted to reach out to him explaining, exactly how this method works, because it really is something that's fun to perform and is a valuable skill. I think we would love to see high school students come out and, get that experience surveying, and just some actual experience out in the field is great, and would definitely build some scientific minds.
Buddies?
Okay, so I definitely agree. I think it was an amazing experience. As mentioned before by Danielle, this is our first time really going hiking and backpacking, and I would love it if younger generations can take part in this as well and be inspired at a younger age. However, there are some limitations because some of these hikes are very difficult. So whatever the high schoolers that would be joining in this and partaking in this would have to be prepared and have to really know what they're getting into, but it's definitely worth it. And I think we should reach out to the younger generations and inspire them at an earlier age.
That's great. And I want to say, given that it rained all summer, it was alternately really hot and really cold, and this was your first hiking experience, hats off to all three of you.
Thank you.
That's not easy hiking. One of the questions we got was they thought that you mentioned a peak named Dink, D-I-N-K, and an anonymous attendee describes themselves as a geezer, which means an old person like me, member of the Catskill 3500 Club. So can you tell him where Dink is, or is that classified information?
So Dink is part of the Balsam Cap Friday Mountain Ridgeline. We did those all kind of in 2 days. So I believe it's in the ridgeline. If you know where Balsam Cap is, you can find ink.
Great. Ava, any more questions, or have we run our questions?
We have one last question, and then we can close things out. So the last question, counterintuitive to this person that the established trails had lower impact on the birds, and they're asking for any further speculation on that.
Yeah, we were actually really excited to see that result as well. One of the thoughts was the idea that like formal trails, they're really quick to walk across. And one of the biggest factors when there's human disturbance on birds is the time that you're spending in proximity to birds. So the longer time that you're walking across a trail, a more difficult trail and a less established trail would make you near birds and their nest longer. You'd be disturbing them longer. They would be impacted by you more, perhaps. So yeah.
So Ava, we're a minute over. Do we have time for one more?
I suppose we could do one.
Okay. I'm gonna ask the question more succinctly. Is there any evidence of forest fires up where you were working in your study areas?
For us, we didn't see any evidence of forest fires, but we did do a couple of samplings when there was like the fires from Canada, so we had a lot of smoke, but just campfires mostly, and nothing above 3,500 really.
Mhm.
A day or two where we had a haze, but typically when the smoke was really bad, we just decided not to make the call.
Yeah, I think preserving your lungs is not a bad idea. Ava, do you want to say farewells and then I'll say a few words?
Yes, absolutely. And I will, we will share some of these findings when they're at a phase 2, go out in a broader public setting. And if you have further questions that are burning, definitely feel free to reach out to the Catskill Science Collaborative and we'll make those connections. But again, I want to emphasize the thank you to our fellows. And at this point, many of their mentors and advisors were in the audience tonight. And we heard some thank yous before, but the work that you saw was at such a high professional level because of the qualities and traits of our fellows, and also the really in-depth mentorship that they received. So I do want to say thank you to all of those mentors and advisors on behalf of the Catskill Science Collaborative. And I'm happy to hear that these partnerships will continue beyond, the formal close of the fellowship program. That's really important and great to hear that you all will continue working together and stay close, I'm sure, for a long time into your careers. So thank you, and over to you, Josh.
Well, I also want to thank the fellows for a spectacular set of presentations. You guys have really great graphic presentation skills, and I think it's really wonderful. You were clear, you were concise, and you were full of data, which was marvelous. The managers, the academics, everybody who mentored these students deserves our heartfelt thanks. I think in the fellowship funding from DEZ, there's a little money to support the mentors, but let's just say if we did an hourly pay scale, we would probably not be making minimum wage. And so the heartfelt thanks for the devotion that everyone shows for this. Ava has done a paper, which we're going to get published eventually, which shows that what we are trying to do seems to be working, right? We are building scientific capacity, but seeing it in these presentations is remarkable. And finally, after thanking the DEC, the DEP, and our donors, I want to thank Ava. Ava is slowly extracting herself to become head of sustainability at the Deerfield School and a PhD student at Antioch, New England, and raising a couple kids just because it's fun. And so the poor woman has suffered me as a boss for a couple of years. I am very sad to see her go, but I will quietly announce that one of our former fellows, Joy Damon, will be stepping in and be the next Catskill Science Collaborative coordinator. So guys, look at this. You can go from being a fellow to being a coordinator. Joy is a very different person than Ava and has different experience. So as always, it will depend a lot on who we hire, but I have faith that she will be energetic and intelligent and comes out of this process really well trained. So we are looking forward to continuing the collaborative and expanding it and doing new things next year. So thank you all and have a wonderful evening and hope you get some dinner. All right, Ava, anybody else, there's some things, let's not kill it quite yet because there's some wonderful comments coming in. We'll try and save the chat so we can send copies out to the fellows. Anyway, thank you all for coming. We had a wonderful turnout tonight and really appreciate it.
Good night, everybody.
All right.